Hi, and welcome to my video on the review of log rules. This is the first video in the new unit on logs and natural logarithms. And to review the rules makes it easier to deal with these units. So let's look over some of the rules and review. And also remind you that in my Algebra 2 section on exponentials and logs. If you have that done in grade 11 or grade 12, then this in pre-calculus, this is going to be a little bit rougher. The question is going to be a little bit more difficult. So let's review the rule. The power rule. The log of a to the x base b is x log a base b. So the power of the a moves in front of the log. And to illustrate that, change each to x log a base b. The 4 moves in front to give you the log of 3 base 2. The 2 moves in front of the log to give you the log of 6 base 5. And the negative 2 moves in front of the log to give you the log of 7 base 3. So this exponent moves in front of the log. The 2 moves in front. The 4 moves in front. And let's reverse it. Express each as the log of a to the x base b. That means that we have the log, and the 7 goes to the power of x base 4. The 3 goes to the power of 2. The base is 10. We could also change that to the log of 2 cubed is 8. And the 1/2 goes to the power of 25. And 25 to the 1/2 square root of 25 is 5. Another rule that we need to be aware of is the product rule. The log of a product is the sum of the logs. So the sum, the product is the sum. And also think about it, I think of it this way. When I'm multiplying exponentials, I add. So the log of a product is the sum. So express each as the sum. So 22 is 2 times 11. So that's the log of 2 plus the log of 11. The log of a product is the sum of the logs. This is a product. So we have the log base 5 of 9 plus the base is 5, and we have an x minus 1. So the sum of logs is the log of the product. Notice the base is 5, 5 goes in here. Express each as a single log. Reverse. The sum of 2 logs is the log of the product. So 4 times 7. So that's 4 7s are 28. So the log of 28 base 3. And this is the sum of 2 logs. So it's the log of the product, x times x minus 6. And that can also be x squared minus 6x. But that has to go in brackets. So you can leave it like this or like this. But if you got to put brackets around x squared minus 6x. And we have the sum of the logs. So we have the log of base 2. Notice 2, 2, 2. So we have a 10 times a 3 times a 1/6. So we can do a couple of ways. We can say 3 times 10 is 30. 6 into 30 goes 5. We can cancel 3 once. 3 into 6 goes 2. 2 once. 2 into 6 goes 5. 5 times 1 times 1 is 5. So this is the log of 5 base 2. Let's continue. The quotient rule. And the quotient rule is division. Quotient means division. So the log of a divided by c base b is the log of a base b. Subtract the log of c base b. And again, when you're in terms of exponentials, when you're dividing exponentials, you subtract. So the log of a quotient is the subtraction of logs. So write each as the difference of logs. So So that's the log of 11. Subtract the log of 3. And this one, this is quotient of log, division of log, division of the log of a division. So we have base is 7, so it's an x, subtract, base is 7, and we have an x plus 4. So the log of a division or quotient is the subtraction of logs. Express each as the log as logs of a quotient. So we have the log base 3 is in each. So we're subtracting. The subtraction of logs is the log of a division or quotient. So 17 divided by 11. Again, the base is 10. They're the same. So this is the log of 2x minus 9 divided by 5. So the log of the subtraction of logs is the log of division or quotient. Express each as a single log. So we have log 3 base 2, log 7 base 2. So we got a log, so we need a log 2 here. So that's a 2, and that's a 2. We need a 2. So think about it. We got a 2. So 2 is equal to log. We need a base of 2. So what number are we going to put here? So this is the base. That's the exponent. X is the number. So we need to put a 4. So 2 to the what power gives us 4? 2. So if we got a 2 here, that must mean that this number is 4. Now we can write it as, we got base is 2, so it's 3 times 7 times 4. So that's the log of 21 times 4 is 84. And here we have the same basis. We have an addition and a subtraction. So the addition is a product, so it's 15 times 10. And subtraction is a division or quotient. So 5 into 25 goes 5, 5 into 10 goes 2, 5 into 5 goes 1, 5 into 15 goes 3, so 3 times 2 is 6. We could have also said 15 times 10 is 150. 150 divided by 25 is 6. But notice I'm canceling here because we have a division and a multiplication. Number 3, we have to do the power rule first. We got to do the log of 6. And 2 goes to the power of 6. 20 log of 27. 1/3 goes to the power of 27. So the log of 6 squared is 36. And that's the cube root of 27, which is 3. Subtraction of logs is the log of the quotient. So we have the log of 12. And just look at 27 to the 1/3 for a second. That's the cube root of 27, which is 3. Or 27 is 3 cubed to the 1/3. 3's cancel out because when you have a power you multiply. 3 times 1/3 is 1. You get a 3 either way. And let's continue. Express as a single log. Now, in this one, we have to do the inside of the bracket first because of PEMDAS. So 1/4. So let's take the 2 and move it to the, scratch the 2 out and move it to the power of 8. And scratch the 1/2 out and move it to the power of 16. And so that gives us, the 2 moves to the power, so that gives us the log of 8 squared is 64. And that gives us the log, base is 5. 16 to the 1/2 square root of 16 is 4. Again, we got to keep working inside till we're fully. So this is the log. The subtraction of log is the log of the quotient. I'm doing one step at a time. And so that's 1/4 log base 5. 64 divided by 4 is 16. And log log base 5, 6 power, 1/4 goes to the power of 16. Notice I had to work out the inside completely before I did the 1/4. PEMDAS. So this gives us, if you want to go up here, the fourth root of 16 is 2. So there's the log of 2 base 5 plus the log of x base 5. The sum of two logs is the log of the product. Base is 5. So 2 times x is 2x. So that's the log of 2x base 5. Again, just to remind, 16 to the 1/4. 16 is 2 to the 4. Because you're multiplying powers, you cancel. 4 times 1/4 is 1, so 2 to the 1 is 2. Or that's the fourth root. 1/4, 4 goes as a root, and that's 16 to the 1 or 16. The fourth root of 16 is the fourth root of 2 to the 4, so it's a 2. And another rule, the log of b to the x base b is x. Evaluate each. So we have the 3, because 3 is the power, and we have 2 bases are the same, 2 bases are the same, so we have a 2, and 1/6 is 6 to the negative 1, so the 2 bases are the same, so we have a negative 1. And just think about it, we could also say that 2 cubed is 8. So what power of 2 gives you an 8? 3. And the log of a base b is the same as the log of a divided by the log of b. Write each as a quotient of logs. So quotient is division of logs. This is the log of 14 divided by the log of 5. A quotient of logs, the log of x plus 6 divided by the log of 7. And expressed as a single log, so this is the log of 9 base 4. And this is the log of 2x minus 1 base 3. So the log of a base b is the log of a over the log of b. This is a rule that if you keep it in your head, sometimes it makes the manipulation of the math easier. Another rule is 1 over the log of a base b is the log of b base a. So the number and the base change around. So this one is log. So 11 goes to the number and 3 goes to the base. And the log of 5 goes to the base, 2 goes to the numbers. You just flip them around. Find the value of each. This is reciprocal, so log. This is 16, that's a 2. So what power of 2 is your 16? 4. And we got a reciprocal again. So this is the log of the 9 base 3. Reciprocal, this is the log of 8 1/2. And notice the bases are different, so we can't divide here now because the bases are different. So this is base 3, this is the base of 1/2. So 3 to the what power gives you 9, so the answer is 2. 1/2 to the what power gives you 8, so 1/2, 2 cubed is 8, but it's a negative 3 to flip it. So it's 2 plus 3, 5. And another one, we got reciprocal, so this is the log of 9 base 6. Flip this one, switch, I should say, 4 base 6. And it's the sum of two logs, the bases are the same, so that's the 9 times 4. The sum of two logs is the log of the product. That's the log of 36 when the base is 6. So what power of 6 gives you 36? The answer is 2. And another rule that is expressed sometimes, the log of a base b times the log of c base a, they cancel out, and you get the log of C base B. And just to show you that, this is the log of A divided by the log of B times this is the log of C divided by the log of A. The log of A's cancel out, so that gives you the log of C divided by the log of B, and that can be written as the log of C base B. Find the value of this product. So we get the log of 2 base 5, the log of 125 base 2, the 2's cancel out. That becomes the log of 125 base 5. 5 to the what power gives you 125? The answer is 3. And let's continue. The more practice, the better we're prepared to complete this unit. Write as the sum of logs. But we can't write as a sum of logs until we have a log of a product. So this is a subtraction. So we got x squared minus 4x, so x can factor out as x minus 4. Now we have the log of a product, so that's the sum of the logs. But to write as the sum of the logs, we needed a product. So we had to factor this binomial to get a product and then express it as a sum. Write as a single log. So this is the log, it's a subtraction. Bases are the same, they're tens. So we get 3x squared plus 3x. Subtraction of logs is the log of the division. And so that becomes log. So notice 3x squared and 3x. 3x is common as a factor. So 3x squared divided by 3x is x. 3x divided by 3x is plus 1. Now do we have it factored? X plus 1 is a common factor, so we scratch them out. So this is the log of 3x as a single log. But we notice a little tiny bit different is what makes the math great, because we can do different skills as we do more topics. Now we have the solve. This is the log on the left side equals a number. So what we have is that the log base exp number. So we have base exponent number. This is the log form. So we're going to take the left side and make it into a single log and then use this. But we got to do this power first. So this 2 goes up to the power of 3, and that makes that a 9. And this is the base 6 here. 2. And so 3 squared is a 9. Now we've got the sum of logs is the log of the product. And now we have a single log, so that's the base, that's the exponent, and that's the number. So 6 squared equals 9 times x plus 2. 36 is 9x plus 18. We can leave the 9x there or move it. If we leave it there, we get 36 minus 18. So 9x is equal to 36 minus 18 is 18. Divide by 9. So divide by 9. We get x is equal to 2. And we check it out. 2 plus 2 is 4. So 9 times 4 is 36, which is the same as x squared. So 2 is the answer. And we have another one, again with the logs on one side, on the left. So we make it into a single log. We have a 1 and a 1, no more, we have no powers. So this is the log. Base 2, got to be the same bases. So this is x minus 1 divided by 4x. So the subtraction of 2 logs is the log of division. Now we have a 1 log, so we go base, exponent, number. That's the base, that's the exponent, that's the number. 2 to the negative 3 is 1 over 2 cubed, which is 1/8. X minus 1, 4x. Cross multiply. 8 times x minus 1 equals 1 times 4x. It's 8x minus 8 equals 4x. Move the x's to the left. Numbers to the right. 4x equals 8. Divide by 4. X equals 2. Let's check it out. 2. 2 minus 1 is 1. 4 times 2 is 8. And this is division, so 1 divided by 8 is 1/8. And 1/8, 2 to the negative 3 is 1/8. So we're okay. So the answer is 2. And some more equations to solve. This time notice that we have logs on both sides. So we have to bring each side to a log and then make the expressions equal. But we have base 2 here, base 2 here, base 2, but we don't have a base 2 here. So log 2, 3x. So I'm writing all this down. So we need a base of 2. So what number do we put here to get? So just think 1. 1 is the number, so we need to find a number. So let's call that number a. So base is 2, exponent is 1 equals a. So a is 2. So let's check. Notice I wrote a little tiny equation. I said, what number I'm going to put here, base 2, to give me a 1, and I worked it with the exponential. So 2 to the 1 power, 2 to the 1 gives me a 2. So perfect. Again, two bases are the same, so we get a 1. 2 to the 1 gives me a 2. Now, we have subtraction of logs, so that's the log of a division, so 3x all over x minus 2. And this is a division. Subtraction of 2 logs is the log out of a division. So we got the log base 2. So we don't cross them out. We just say, we don't cross them out like that. We just say that 3x over x minus 2 equals x over 2. Because both sides has log of this expression, base 2, and log of this expression, base 2, these two expressions got to be equal. Cross multiply, x times x minus 2 equals 2 times 3x. I could have multiplied 2 times 3x first equals this. So that gives us, it'll all work out no matter what you do. But I noticed that when I looked at it, I was having a quadratic because of the x times x. So I put the quadratic on the left side. So I wouldn't have any negatives with the x's. So bring the 6x to the left, make it negative. X squared minus 8x equals 0. X is common, to take the x out by factoring. X squared divided by x is x. Negative 8x divided by x is 8. So x is 0. X minus 8 is 0. So x is 8. So let's sub back into C. 0. 3 times 0 is 0. The log of 0. You can't do it. Nope. Once it don't work with one of them, you don't have to go any further. You don't have to check them all. Try an 8. 3 8s are 24. Positive. 8 minus 2 is 6. That's positive. So let's check. 24 divided by 6 is 4. So the left side becomes a 4 base 2. And so that's a 2. And this side here, the log of x is 8. So that's the log of 8 base 2 is a 3 minus 1 is a 2. So 8 is the answer. 0 you can't use. And we have another equation with the logs on both sides. So we have to simplify each side to a single log. But before we do that, we have to move the number in front of the log up with the power rule. So the half goes to the power of 9, so that gives you square root of 9 is 3. And again, notice I'm doing one step at a time. Power rule, 12 squared is 144. And so this is the log of, the sum of two logs is the log of the product. And the subtraction of two logs is the log of the quotient. And so I could take shortcuts, but 144 divided by 144 divided by 24 is 6. And we have the log on each side, so that means that 3 times negative 2x plus 8 equals 6. Multiply, we get negative 6x plus 24 equals 6. Negative 6x equals 24 minus, or negative 6x equals 6 minus 24. That means negative 6x equals negative 18. Divide by negative 6, x equals 3. And check 3. And negative 2 times 3 is 6. And 6 plus negative 2 times 3 is negative 6. Negative 6 plus 8 is 2. And so that's positive, that's okay. So the square root of 9 is 3. So 3 times 2 is 6. And this works out to be 6. So 3 is okay. 3 is all right. Now, it says find the value to the nearest thousand. Okay. Let's find value to the nearest thousand. And let's see, so the log of 41 base 3 is the log of 41 divided by the log of 3. And we take our calculator and manipulate the log of 41, turn it on, log of 41, division, log 3. And we get 3.3802, so the answer is 3.380 to the nearest thousand. And let's work this one out. This is the log of 6.3 divided by the log of a half. So we clear that. Log of 6.3 bracket division. Log of a half is decimal 5 or 0.5. And we get a negative 2. Nearest thousand, this is less than 5, so it's 655. Negative 2.655. Find the value of x for each. Now the value of x that we're using here, this is the number, so negative x minus 4 has to be greater than 0. Negative x is greater than 4 when you move it over, plus, divide by negative 1. So x, negative 4 divided by negative 1 is negative 4. When you divide an inequality by a negative number, it changes direction. So all values of x less than negative 4, not equal to negative 4. And if you check it out, let's take a number called 10. 10 is not 10. You can't use 10 because 10 is not less than. Let's try 10. That's the negative of 10. Negative 10 minus 4 is negative 14. You can't do a log of a negative number. If you use negative 6, the negative of a negative 6 is 6. 6 minus 4 is 2. Okay. Here, x minus 2 is in the base, but the base has got to be greater than 0, and the base can't be 1. So that means x minus 2 got to be greater than 0, and x minus 2 cannot be 1. So x is greater than 2. Move it over. And right here, x cannot be 1 plus 2. X cannot be 3. So any number greater than 2, you can't have 2. 2 will give you 0. You can't have log, base can't be 0. Got to be greater than 2, but it can't be 1. So when we have 3, 3 minus 2 is 1, so we got to be greater than 2 and not 3. So all the numbers greater than 2 but not 3 fits this problem. Allowed to work. So that brings us to the end of reviewing the log rules to help you out. This is the first video. More is coming. And if you like my video, click the like button. If you want to be a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.